Welcome to the lecture videos on Chapter 32 on the topic of inductance. In these videos, we'll be first talking about inductors, which are devices, and inductance, which is a property of different devices. Mostly we talk about it of inductors that describe how they function in circuits. So this is following the same sort of pattern we saw in our discussion of electrical stuff. So when we saw electrical stuff, we said, here's how the force works. We talked about electric force and electric field, Gauss's law, electric potential energy. And then we were like, okay, let's talk about circuits and how these concepts are used in circuits. So we talked about batteries and EMF sources. We talked about capacitors. We talked about resistors and circuits that are combined of them. Now what we're going to do, having talked about magnetic stuff, said, okay, here's what a magnetic field is and how it creates force, and then what are the things that make that force. That's the next chapter. Magnetic induction, which is kind of an interesting thing with magnetism, but it's not directly derived from the previous chapters. And now we're going to talk about how this magnetic induction is useful in circuits. We're going back to circuits. It allows us to make a new circuit element called the inductor. Okay. Um, so once we talk about what an inductor is and what inductance is, we can talk about circuits in containing inductors. So the first one we'll talk about is what happens if you know an inductor and a resistor in a circuit. That's called an RL circuit. Then we'll talk about how energy is stored inside of an inductor and how magnetic fields have energy. Then we'll talk about how there is a different property similar to inductance, which is maybe more aptly called self-inductance. There is a property that relates to different objects to each other and how they interact, called mutual inductance. We'll talk about that property. And then we'll talk about, okay, let's get into what happens of more combinations of circuits. What if you have an inductor and a capacitor hooked up together? In that case, you get oscillations in current, and we'll talk about what those look like. What happens if you have an inductor, a resistor, and a capacitor? All the three of the circuit elements, main circuit elements we've talked about so far. What happens if you put those together? And we'll talk about the type of oscillations you get there. Now, a lot of the effects you get with having inductors and capacitors and so forth is very analogous to a mass on a spring and simple harmonic motion. We'll spell it out at the end of the chapter discussion exactly what the correspondence is. But this is a great time, if you haven't done it already, is to go back to simple harmonic motion and brush up on those topics. Masses on a spring, what is a period, what's angular frequency, what causes it, how do you describe it, that sort of thing. Because you can take all of your intuition about how that stuff works, like especially damped harmonic oscillation and damped driven harmonic oscillation. Remember those things like resonant frequency, bringing those ideas, applying them here to circuits where the math is almost exactly the same, the behavior is almost exactly the same, but it's much less intuitive, and because you've seen probably things bounce on springs before, but you probably haven't seen, you may have not seen circuits operating. And even if you see a circuit operating, it's not visibly usually doing anything, so that you can keep track of what's going on with the current and the voltage and so forth inside of it.